Perception systems in living organisms have been parsimoniously evolved over the years, from jumping spiders to frogs and bats. These bats are the silent master of the night, proving that true vision goes beyond their eyes. Contrary to popular belief, bats are not blind. They combine information from their multimodal sensors, echolocation, and their eyes to precisely perceive the surrounding. Drawing inspiration from nature's multisensory approach, we introduced TinyDepth, a novel method for generalized dense depth estimation tailored to enable navigation capabilities in merely palm-sized robots by observing the unknown environments from two different views. Our system is designed with an RGB camera coupled with a 64-pixel sparse depth sensor, enabling us to be only a fraction of industrial-grade depth sensors, both in terms of size and weight, making it a perfect match for our onboard tiny autonomous robots. We show the feasibility of our model in various novel scenarios on different robot modalities. Our palm-sized autonomous car uses our TinyDepth model that enables our robot to navigate in unstructured environments. We also demonstrate our method to navigate our bee drone in order to detect the unknown gaps and traverse through them. Due to our exceptionally small sensor suite, our robots can be equipped with multiple of these systems, enabling them to sense in all directions. We achieve a success rate of 87% over 100 trials in never before seen environments. Finally, we believe our system provides a pivotal step towards tiny robot autonomy by exploring the principles of minimal perception.